Hi, for our next video what we're doing is we're looking at breaking down hydrocarbons, explaining why we need to do it, and looking at the products that are produced when we actually break long chain hydrocarbons. So what I've got here first for you to look at is something you might get as an exam question. It is a graph of supply and demand. If you do business studies you may have seen one of these before. What I've also done is I've also included some of the properties we've looked at previously about the hydrocarbons and the fractions. So if we start here, so what I've got down here is the percentage of original of the hydrocarbon in the crude oil. Okay, it goes up to 50%. And then I've got the different fractions down here. So I've got gases, petrol, kerosene, diesel oil, fuel oil, and bitumen down here. So as you can see, I've got flammability. So down here with starting with gas, we go from high flammability, how easy, and remember flammability is how easy can it light. So the gases light really, really easily. And as we move across the graph, they move from high to low flammability. Bitumen is really, really hard to set fire to, which is a good thing. We've got as well viscosity, and if you remember, viscosity is how something flows, how thick it is. Here we start with low viscosity with the gases, so they're thin, they flow very, very easily, and as we move across we go from low to high viscosity. Down here with bitumen we're looking at something which is very thick, it flows very, very slowly. And I've also put the length of the hydrocarbon chain as well. So down here with the gases and the petrol we've got short hydrocarbons. Those carbon chains get longer and longer as we move across from the gases to petrol to kerosene to diesel oil to fuel oil to bitumen. And down here, so bitumen is actually a very long chain hydrocarbon. It contains hundreds and hundreds of carbons. So if we look at supply and demand, I'll just move that across so you can see. So supply is in green, and supply is how much there is in the crude oil that is extracted of each fraction. And demand is in pink. Demand is us. It's how much we actually want something. Okay, so it's how much we actually want something. So if we start with the gases, gases have a very low supply. There's actually a much higher demand than there is supply. So we want the gases. They're great fuels. We can use them in the home. So methane, for example, is used in the home for cooking, for heating. Butane, for example, is butane propane, and use there your barbecue gases. Okay, so there's a high demand for those, but not a lot actually in the crude oil. Petrol's a really, really big. Petrol and diesel, we look here, petrol and diesel, really, really big ones, and kerosene as well. Okay, so these are your fuels. Okay, petrol for cars, diesel for cars and trains, kerosene for planes. There's a relatively low supply. There's not a lot of it in the crude oil, but we want it. Okay, there is a large demand. There is a massive demand. If you look here, the supply is really, really outstripped by the demand for petrol. Okay, maybe not at the moment with everyone staying at home, but in general, we want these fuels. And it goes the same. The pattern's the same with kerosene, although not quite so drastic, and also with the diesel oil as well. Again, not quite so drastic. As we move down, however, we go to fuel oil. There's a massive supply of fuel oil. Okay, massive. Nearly 50% of in this example of the crude oil is the fraction that is used for fuel oil. Fuel oil is used. Some people use it in their home to heat their homes if they live off the grid. They don't have gas. It can be used in big tankers. We don't want it so much. Yeah, there's not such a big demand for it. And bitumen, again, look, compare the supply. Okay, in green to the demand. Okay, bitumen is used for roads, for tarring roofs, etc., etc. We need it, we use it, just not as much. Okay, and there is a big, big supply. So we have more of these. If you look here, we have more of these long chain hydrocarbons than we do the short chain ones. However, we want the short chain hydrocarbons more than we want the long chain hydrocarbons. So what's the solution? What could we do? And the clue's in the title. Break down hydrocarbons. These long chain hydrocarbons can be broken down, and they can be broken down in a process called cracking. So cracking, I'll put that down there for you. So cracking, so that's your title here. So cracking into the process of breaking down long chain hydrocarbons I'll put this down here, into smaller, more useful ones. And I'll put up a video for you to have a look at that process. So what we've got is basically, I'll run through it quickly. We take our long chain hydrocarbon and we place it into a test tube. We have what we call a catalyst. Now, this catalyst is in the lab, we tend to use little broken bits of ceramic pots. And what we do is we heat them up. It needs to be a hot catalyst. And then what we do is we heat the long chain hydrocarbon to vaporize it. Turn it into a gas, and that hot catalyst keeps it as a gas because it's the gaseous products that we want. And then we recondense them down here in the product. A catalyst, if you're not aware of it, you may have heard of it in biology. A catalyst is a substance that speeds up a reaction and is not used up in the process, and is not used up in the process. Okay, so that's what a catalyst does. So what are the products that we get? So I've got an example here for you, and you might want to write this one down. So there we have our decane. For this example, I'm using decane to represent a long chain hydrocarbon. Let me just check, make sure it is decane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 carbons, dec. Okay, so C10H22. And then what we do is we heat it. No other reagents are involved. We heat it. It's what we call, and I'll just write this here, it's what we call a thermal decomposition reaction. And that basically means we're breaking something down using heat. So I'm going to break this long chain hydrocarbon using heat. And I'm going to get two products from that. The first product is my very, very useful shorter chain hydrocarbon. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so I've got C8H18. What's the name of that? You should know that by now. It's octane. Octane forms part of the fraction for petrol. So it's the very useful one. We go back to our graph. Remember that demand for petrol. So that one's really, really useful. So we've used we've got our first product. What have we got left from here? Remember, I've not reacted this with anything, so I've only got 10 carbons and 22 hydrogens to use. So I've still got 2 carbons that haven't been used, C2, and I've still got 4 hydrogens that haven't been used, C2H4. So this is a new product to you. Okay. Okay, it's called ethene. Okay, not ethane. Okay, because if you remember, ethane is C2H6. This is called ethene, and it's from a family of hydrocarbons called alkenes. And I'm going to look at those in my next video. So your key points of cracking. Cracking is the breaking down of long chain hydrocarbons into smaller, more useful ones. The process, you have to heat and vaporize the long chain hydrocarbon. You have to pass it over a hot catalyst and collect the product. It's a thermal decomposition reaction, which means it breaks down using heat. And our example, it produces the products. So the products are a shorter chain hydrocarbon, or a short chain hydrocarbon, which is an alkane, and an alkene. And if you notice, there's a double bond there. And we're going to talk about that more in our next video. Okay, but why do we do this? Last little bit, why do we do this? Because of this, because of supply and demand. We have lots and lots of long chain hydrocarbons, but the usefulness of them is limited. We want shorter chain hydrocarbons because they're used as, very importantly, they're used as fuels. They produce lots of energy when burnt. Okay, thank you. So in the next video, we're going to look at alkanes versus alkenes. Bye-bye.